All right, so with this video, I want to take a look at questions 54 and 55, and you'll notice that we're still dividing, we're still performing division, except we are no longer dividing by a single term monomial, right? Now our denominator is a binomial, two terms, and we can no longer rewrite each term of the numerator over this denominator because this is not a monomial. You can only do that when the denominator is a single term. Now we have to perform one of two different types of division. Either we can perform synthetic division or we can perform long division. And because we have two examples here, I'm going to do number 54 with synthetic division and then number 55 with regular long division, and that way you can see two different ways of performing division, and maybe you'll like one over the other. With synthetic division, however, it's important to remember and take note. You can only perform synthetic division when the coefficient of your variable, whether it's x or m or h or g, whatever they're using, the coefficient has to be 1. If it's anything other than 1, you cannot use synthetic division. You have to use long division. All right, but 54, because the coefficient in front of our x in the denominator is 1, we can use synthetic division. All right, so let's go ahead and set this up. Now, with synthetic division, you are going to take whatever the sign of the second term of this denominator is, of your denominator, and you're going to take the opposite sign and put it outside the little house you set up. So if we have a plus 3, in this case, we're going to take a minus 3, set up our little house, and now inside this house, we are going to write the coefficients of our numerator in descending order of degree, and make sure to fill in any zeros, or fill in rather any missing degrees with 0, meaning make sure you go from 2 to 1 to none. If we skipped a degree, if we went right from x squared to 21 and we were missing our first degree power, then you would have to fill in that first degree power with a 0. Here, however, we go nicely from 2 to 1 to none, and so we don't have to worry about that. All right, so let's write our coefficients. What is the coefficient of the x squared? Well, it's a 1. And what is the coefficient of our single x? Well, it's 10. And what is our constant? Well, it's 21. And now we're going to go ahead and draw a line and leave some space here because we're going to be writing some numbers in here in just a second. And it's important to remember that no matter what this first number is, your first coefficient always comes down. So bring whatever this number is down. And now we're going to start the process of multiplying what's on the outside by what's on the inside here. So we do negative 3 times 1 gives us negative 3. And then 10 minus 3 gives us 7. And now negative 3 times 7 gives us negative 21. And 21 minus 21 gives us 0. And since there's nothing else here after this 21, we know that we can stop and 0 this number here, whatever the last number is in your string of numbers under this line, becomes your remainder. So in this case, we have a nice remainder of 0. And now what you have to do is you're going to go back and take a look at what numbers you have. And in this case, we have a 1 and we have a 7. And because our numerator started with a second degree, it started with a square, we are going to drop 1 power and start filling in. So we're going to go from 2 to 1, and then and then start filling in. So 2 to 1. Well, after 1 comes none, so we just have a plus 7, right? Because 10 minus 3 was a positive 7. And so this actually is now our answer. So we have x plus 7 is the result of our division of x squared plus 10x plus 21 divided by x plus 3. All right, let me go ahead and show another example. You know what, let me do this one by synthetic division also, because I think we have two others that we can show with long division, just so you can start to get the hang of synthetic division, because this is a quicker way than long division, but it does take a lot of practice to make sure that you have the process down. So make sure you're doing your homework and getting the practice that you need. All right, so again, we want to double check to make sure that the coefficient in front of our variable, m this time, is 1, and it is. We know we can use synthetic division because of that 1, and it's a binomial here in the bottom, so let's definitely make sure we're using the proper division. And so again, whatever the sign of that second term is of the denominator, you want to take the opposite of. So in this case, we have m plus 9. So on the outside of our house, we're going to have a negative 9. Take the opposite sign of whatever that term is on the bottom. All right, we're going to draw our house. And now inside the house, we're going to take the coefficients of each of our terms of the numerator. So we're going to take our 2, we're going to take the 11, and we're going to take our negative 63. And it's important that you take the signs with you, right? Up here, all of our coefficients were positive, and so all of the numbers that we brought in were also positive. Here we had positive 2, positive 11, so the signs we don't really have to write, right, when they're positive. But because our last constant was negative, we took that negative sign with us. All right, draw our line, leaving some room because we're going to be writing numbers here. And now again, this 2, this first number always comes down. And so we're going to have 2, and now let's start the process. Negative 9 times 2 gives us negative 18. 11 minus 18 gives us negative 7. Negative 9 times negative 7 is positive 63. And so negative 63 plus 63 gives us 0. And again, because there's no other numbers after this negative 63 to work with, this is going to be our remainder. So the last number in your string of numbers under the solid line is your remainder. All right, well now we have a 2 and a negative 7, and we want to fill in our variables, right? Because we have m's, and our final answer is likely to have m's, but we don't know how many to use until we go back to the original numerator and see that we started with a 2. And since we started with a 2, we're going to drop 1, which means we're going to go from 2 to 1 and start filling in our answer. So we go from 2 to 1, and then notice that after 1 we go to none. We have our constant. So this is 2m to the first minus 7, and 7 is going to be our constant. And so now we have our answer of 2m minus 7. Let me go ahead and just really quickly, let's see. If we, let's say, we're dealing with, this was a 4, for example, and we had a much longer numerator that we were working with, and it went from 4 to 3 to 2 to 1. Well, in our final answer down here, when you start filling in, if the highest degree was 4, then you would drop 1, and you would have 3, and then you would start filling in, and then you would have 2, and then plus m, and then plus your constant. So the number down here would be a lot longer, and you would have room to fill in. All right, so it's just important to remember, go back to that original numerator, drop 1, go to the highest power, drop 1, and then start filling in the numbers as you go along. Because we went from 2 to 1, we only had to fill in a single m, and after the first degree power, we go right to our constant, don't we? Just like up here. After our first degree power, we went to the constant. After the first degree power, we went to the constant. And so that's how we know that our negative 7 doesn't get any variables, because the m here is m to the first, and right after your first degree power, you go immediately to the constant. All right, let's take a look at number 56 and 57 in the next video, and maybe we'll do one more in synthetic division and then take a look at long division.